Given the function f of x equals x squared minus x minus 6, which of the following describes the values of x for which f of x is greater than 0? Ugh. So this is what we have to do here. We have a lot going on. We have to find zeros, we have to find holes, and we have to find vertical asymptotes. Not only should we do that, we need to find the end behavior of what's going on here, and we really should find out what the y-intercept is. So let's leave that looking like that because I'm going to come back and reference this in a minute. Okay. What I also want to do is I want to factor out the numerator and the denominator because that would give me holes, vertical asymptotes, and zeros. So f of x is going to be factored out x minus 3, x plus 2. On the bottom in the denominator, we have x minus 3, x plus 3 because it's difference of squares. Now let's find the magic numbers, the numbers that would make each factor equal to 0. Your magic number is 3, your magic number is negative 2, your magic number is 3, your magic number is negative 3. So that would give you a, let me see, 3 and 3 repeat, so we would have a whole at x equals 3 because we have repetition there, top and bottom. Negative 2 is a magic number living alone in the numerator, so that is a 0 at x equals negative 2. And negative 3 is a magic number living alone in the denominator, so I'm going to have a vertical asymptote at negative 3. So if I were to draw some important information on a coordinate plane, if I were to sketch this, what I have so far is I have a hole happening at 3, I have a 0 happening at negative 2, and I have a vertical asymptote happening at negative 3. So this happens so far. What I also need to find out is a y-intercept and a horizontal asymptote. Let's do the horizontal asymptote first. Now the horizontal asymptote is going to live whenever you have either the degrees are the same in the numerator and the denominator, or the degree in the denominator is higher. You're going to have a horizontal asymptote. These are the same. So my horizontal asymptote is going to be at x squared over x squared. You're looking for the leading coefficient divided by the leading coefficient. Each leading coefficient is 1 and 1. So I'm going to have a horizontal asymptote at y equals 1. So if I were to call u1, this happens, horizontal asymptote at x equals 1, y equals 1, sorry. Now the other thing that I didn't find out is where this is going to be my y-intercept. My y-intercept happens when you have the constant number in the numerator divided by the constant number in the denominator. That is going to be my y-intercept, and that's going to happen at negative 6 over negative 9, which is going to be 2/3. So this is going to happen. Okay? So let's again evaluate what we have. We have a hole at 3. Okay, this is going to go through negative 2. Okay, now it levels out at 1. So since starting from the left, I have a picture that levels out at 1, right, but doesn't go through any zeros at all, and then all of a sudden explodes here at negative 3. What this is going to look like is it's going to level out at negative 1 or positive 1 and then go like this. That's what I have so far. Then, since there's no multiplicity ruining things, at negative 3, I'm going to reappear down there. And I'm going to come up and go through negative 2, through negative 2, because it's a 0, through that y-intercept of 2/3, and level out here while hitting a 0 or a hole at 3 right there. So that's going to be what my picture looks like. Now what I'm supposed to do is I'm supposed to find out where this is greater than 0. Okay, so this is going to be greater than 0 here. All right, it's going to be greater than 0 all the way up till negative 3. It's going to be positive. So all the way up until negative 3, it's going to be positive. Then from negative 3 to negative 2, we're negative. Okay, but then from here on out, from negative 2 all the way until positive infinity, we're living in positive land again. So it's going to be positive from negative infinity to negative 3. Okay, it's going to be negative from negative 3 to negative 2, and then from negative 2 all the way on to positive infinity, we're above the x-axis again. Okay, so that is going to be A. And that's how you do it.